Here we're going to look at how to calculate the work done due to a pressure volume expansion. So in the diagram I've drawn on the page, you can see a piston drawn schematically, separating the system from an external pressure. And to start with, the external pressure is 1 atmosphere and the pressure inside the system is greater, and that's 2 atmosphere, which we will denote as P internal or P int. So because the internal pressure is greater than the external pressure, if we release the stopcocks that you see here that are holding the system in place, if we release the stopcocks, the piston will move up. So what's shown on the right is what happens if you release the stopcocks, the piston moves up until it hits the second set of stopcocks shown here. Note that the system will only move up, and when it moves up, it will be moving against a resistance from the external pressure. It's the resistance from the external pressure that causes work to be done. And so we will calculate the work done as minus P external delta V. The delta V term is the change in volume, and it comes from multiplying the distance moved by the cross-section of the piston. The negative sign here means that the energy of the system will decrease. That's our convention, by the amount of work done. Now, notice one thing. There's nothing in the system as drawn here that specifies whether the material inside the system is an ideal gas. It, in fact, doesn't have to be an ideal gas. It doesn't have to be a gas at all, as long as it's compressible or expandable. And if the pressure inside is greater than the pressure outside, then the piston will move up. So one question is, why are we using the external pressure to calculate the work done? Why don't we use the internal pressure? Well, one reason is because it's the external pressure that provides the resistance against work is done. But you can also see that the value of the internal pressure is actually irrelevant, as long as it's greater than the external pressure. And to see that, let's draw the diagram again with the piston, just as before. And we'll put the first set of stopcocks here and the second set of stopcocks here, and draw the piston at the original place as it was in the first example. But now let's make the internal pressure much greater. Let's make it 5 atmospheres. And let's make the external pressure the same as in the first example, 1 atmosphere. Now when you remove the first set of stopcocks, the piston will move up just as it did before. It might move up faster because the internal pressure is stronger, but it'll come to rest where the second set of stopcocks are. And during the movement, what it's been pushing against is the same external force, 1 atmosphere. So, in fact, the work done will be the same. If we change the problem so that we put an extra weight on the piston, then the internal pressure would have to do more work to move the piston, and the work would change. In any case, it's only the external pressure that determines, in this example, how much work is done. So I'll write down the conclusion here. Only the external pressure determines work done. Now, there's an important qualification here, which is that this is true when the internal pressure is greater than the external pressure, because then it's the movement of the internal pressure against the external pressure that's giving us the nature of the work done. The situation will change, however, if we have the following situation. If you start with the situation like this, with the piston as it was before, but now if you imagine that the external pressure is greater, let's say it's 10 atmospheres, than the internal pressure, which is, say, 1 atmosphere, and let's say there's a stopcock holding the piston in place. Now, of course, when the stopcock is released, the opposite thing will happen, and the system will get compressed. And maybe there's a set of stopcocks stopping it here, but now you can see that what will happen is that the external pressure will cause the system to compress against the 1 atmosphere initial pressure that is being compressed in this system. In this situation, work done is against the internal pressure. because it's the internal pressure in this case that provides the resistance to the movement of the piston. So the only role played by the external pressure here is that the external pressure is greater than the internal pressure. And so here, work will be P internal delta V. And we'll keep the sign the same because here actually delta V is a negative quantity and the energy of the system will increase. And the sign on the work will be positive. So the things to remember is that the movement of the piston is determined by which pressure, the external pressure or the internal pressure is the greater. If the internal pressure is smaller than the external pressure, then the piston will move against the internal pressure. And in this case, it'll be the internal pressure that is used to calculate the work done because it is the resisting force.